Hi class. Last time we left off, we were talking about the Rutherford model of the atom and how his experiments proved that atoms have a small dense nucleus with electrons orbiting around the nucleus. But very quickly people started to discuss this model and say it's a great model, it explains a lot, but it doesn't explain everything. And we wanted to speak today about a couple of phenomena that have to do with light being emitted from different elements that really just was a shortcoming of the Rutherford model. People started to say, how do you explain something is missing from the model of the atom because it doesn't explain everything that we observe about materials. And what do scientists do? Scientists attempt to explain things that they observe. Once they've observed something, they try and come up with a hypothesis and theories about what they're observing, and then they go and set about seeing if they can test them and verify if they are legitimate or not. And so the phenomenon that they're trying to explain next in the evolution of the model of the atom is the fact that certain elements give off different colors of light. Now, at this point in time, we know two things. We know different elements, when you heat them up, give off different colors of light, and we know that we can use a prism to break light out into all the different colors of light that are contained within a beam of light. So that's using the refraction property of light, where light will bend and slow down when it goes through a material such as glass. And it turns out that each frequency of light bends a little bit differently, and so the different colors of light or different frequencies within the light separate out when you put them through a prism. But let's talk about how each element looks a little bit differently when you heat them up and they start to give off light. So let's look at a flame test here in action. And what you can see is different elements are being basically burned. They put some alcohol on them to get them to be very hot. And you can see that we've got strontium and we've got different elements here. Calcium is giving us an orange flame. And so this is a phenomenon that was observed for quite some time, and people didn't really understand why do different elements, when you heat them up, give off different colors. Okay, so that's the phenomenon that we want to talk about today, and then in the next lesson we'll try and explain this phenomenon with a different model of the atom. Okay, let's close that one out. All right, so the first phenomenon that we want to talk about is this phenomenon where elements emit different types of light. And again, we're going to take this different light that's coming off of different elements and put it through a prism. And what we notice is that light doesn't turn out to be just one color of light. When you put it through a prism, it turns out to be a combination of very specific colors of light. So for example, this is hydrogen up here. If we heat up hydrogen and then put the light that comes off of hydrogen through a prism, something interesting happens. We don't get one color, and we don't just get a kind of a continuous spectrum of colors. We get very, very specific colors. We get a little bit of this color, a little bit of this color, and this color. When we heat up a different element, such as helium, we get a different set of colors that come out of it. Not all of them are visible. I'm just showing the visible colors here, but there also will be some infrared and some ultraviolet and some frequencies of light that we can't see. And here's mercury. When we heat up mercury, this is a larger atom. We get several colors of light here, but again, very specific colors of light. And here's uranium, which is a rather large atom, and it gives off many, many, many different colors of light. But even here, very specific colors of light. And this phenomenon was observed, and we call that the emission spectrum of an element. The emission spectrum of an element, it's a set of frequencies of electromagnetic radiation. It's just a set of colors, we could think of it as, that are emitted or given off from an element, usually when we heat it up so that it glows and gives off light. That's when we take that light and we put it through a prism. That's when we will see these very specific colors of light. So it's a very interesting phenomenon. And let's look at a little video of that. Here, what we're going to see is some gases being heated up. In this case, let me see if I can just go back for 1 second. This is hydrogen gas being heated up. When you put it through a prism, this is effectively a prism. It's called a diffraction grating. You can see very specific colors of light come out. Okay, only a few specific wavelengths of color come out when we heat up hydrogen. And now helium, when you get helium emitting light, you see more frequencies of light here. So there were several frequencies of light, but they were nevertheless very specific, very very specific colors of light. Okay, so this is one phenomenon. We call that the emissions spectrum of an element. And that is the very specific colors of light that come off when you heat up a particular element. So that is a phenomenon. There's another phenomenon that's very similar to that, which is an absorption spectrum. And an absorption spectrum occurs when you take a gas and you put it into or an element, you put it into its gaseous form. So it's a gas, and you shine light through it. You'll notice, what we notice is that it absorbs very specific frequencies of light. Well, let me show a little video of that, and then we'll come back and talk about it. So here what we have is, out of this device is what we call white light. It contains all the frequencies of light. And then here, what's going on is we're heating up a specific element, and we're going to get basically the gaseous form of that element here. And we're going to see that when you put an element into its gaseous form, that it absorbs very specific frequencies of light. So let's take a look at that. And so what's happening is he's putting you can see this little black line here as he puts as he burns the element and gets it going into its gaseous form. You see a black line appearing here. That means that's showing that it's absorbing the light that's coming out of the light bulb at that frequency. So you can see it absorbs very specific frequencies of light. So a gas, an element in its gaseous form, will absorb very specific frequencies of light. So it's a very interesting phenomenon here. Hold on. And so what you'll see from an element such as hydrogen, for example, is if you heat up the hydrogen itself and you get light coming out of the hydrogen, it will emit very specific frequencies of light. We call that the emission spectrum of hydrogen. If, on the other hand, we have a light source, let's just say an ordinary white light bulb, and we shine that light, but we shine it through a gas like we saw in that last video, hydrogen as a gas would absorb those very same frequencies of light. You can see little dark bands here. Hydrogen would absorb those very same frequencies of light that it would emit when we heated up the hydrogen. So hydrogen will emit certain frequencies of light, and hydrogen, if you shine light at hydrogen in its gaseous form, it will absorb certain frequencies of light. So that's the emission spectrum of an element and the absorption spectrum of an element. And each element has its own unique spectrum. So here's helium. Helium has very specific frequencies that it emits when you heat it up, and it has those exact same frequencies that it will absorb if you put it into gaseous form and you shine a light through it. And this is useful for astronomers. Astronomers, if they know that there's a star out there, for example, that emits a nice continuous spectrum of light, and then a cloud of gaseous material out in the solar system or somewhere out in the galaxy gets in the way of it, and you notice that this cloud is absorbing certain frequencies of light, you can make a determination about what elements are in that cloud of gas. So it's useful for astronomers to analyze elements while they're in space. Clouds of gas while they're in space. Sorry, I was just shutting off the video that was running. And it also tells us this is actually our sun here, and it is showing, again, when you look at the light coming out of the sun, it has certain frequencies of light that are missing here. This is due to absorption. On the outermost layer of the sun, there is a thin, cooler gas layer, almost an atmosphere on the sun. And by looking at which frequencies of light it absorbs, we can make a determination of what type of gas is in that outer layer of the sun by looking at the absorption spectra of the atmosphere of the sun. Okay, so the situation now, after we looked at the Rutherford model, is we said the Rutherford model is a great model, but we need to go further. We need to develop our model of the atom further to explain these phenomenon of elements. That elements will give off very specific frequencies of light and absorb very specific frequencies of light. And this is the next thing that needs to be explained in the evolution of the atom. In the next lesson, we'll explain how a guy named Bohr came up with a new model of the atom that does in fact explain this behavior of elements. Okay, so thank you, and I will please fill out the form that goes along with this, and have a great day.